So our first example were proof questions. This example is a solving question.
Just about the last one, like, do you always just not have to do here?
When you have a proof, you draw the line and you can only work on one side by itself. When you have a solving question, you're allowed to do all the algebra you want to do. So you can move things over from one side to another. You're not trying to prove that it always works. You're trying to find the one specific case or the couple times that it works, because it doesn't always work. So in A is going to be a review of stuff we did at the beginning of Chapter 7 and stuff we did in Chapter 6 with one new little bit. Currently, we cannot solve this question because we have two different trig functions. One of them is sine, one of them is cosecant. If we had all the same trig function, then we could solve it. So we use our identity to start off with by saying, hey, I could get these to be all the same by changing cosecant to 1 over sine. And now, whoa, where'd my equal sign go? There we go. I took the mark off. I erased it and added equal sign. Now we have only one trig function. And at this point, everything is review from stuff you've learned in the past. We have a bit of a rational equations review from grade 11. What did you do in an equation when you had an x in the denominator? Do you remember? You got rid of it out of the denominator. How would I get rid of a sine x that's in my denominator? What would I have to multiply by? I'd have to multiply by sine x. So I'm going to multiply this side, because in math it says what you do to one side, you do to the other side. I'm going to multiply this side by sine x, and I'm going to multiply this whole side by sine x. Now, you started to cheat a little bit probably. Cheat. I don't know if it's cheating. But when you multiplied this side by sine x, do you remember you multiplied this by every term by sine x? That's because when you multiply a whole side, you actually distribute. That's why you do that. So if I multiply this whole side by sine x, I'm going to get 3 sine x, and here my sine x's will cancel, plus 2. What kind of equation is this? It's a quadratic equation. How do we solve a quadratic equation from grade 11? You factor, but before you can factor, you need to move everything over to one side and make it equal to 0. So I'm going to get 2 sine squared x minus 3 sine x minus 2 equals 0. No, as long as you don't forget to write the equals 0. That's an E2. I like moving it to the left side.
The squared has to be before the x, right?
And the squared has to be before the x. If you put the squared after, that's an E. That might be, I'll have to check it. Might be. There's only 10 E errors. It's not E11. No, I think the record is 6 out of the 10 on an exam. You're pulling out all the stops? You will get extra marks, minus 5 of them.
So we get extra marks when we take away 5, so it all balances.
No, the extra marks are negative. They're not positive extra marks. They're negative extra.
Marks a distance.
But multiply by negative 1 and now they're positive.
So now we need to factor. The only way to get 2 sine squared is 2 sine and sine. Can you think what your last numbers would be so that they multiply to give you 2 and your outside and inside make 3? Well, multiply to get 2, it's either 1 and 2 or 2 and 1. In order to get the negative 3, do you see that the 2 has to be on the outside? That makes your outside 4, inside 1. I would need negative 2 for my outside, positive 1 for my inside to get negative 3. Because you have to multiply and add at the same time. Factoring. If you practice factoring. What's that?
Is there anything wrong with doing like a long product sum?
No, you can still use that, although there's a good chance that you'll make a notation error while doing it, so that it can be half-mark deductions.
Yeah, I don't get it.
All right, let's talk about this. What you have to realize when you multiply something out and FOIL, okay, your first ones always make, wow, that's an eraser. Your first ones always make that first one. When you multiply everything out, your last ones always make that last number. Okay? And then your outside and inside always get combined to be that middle one. Does that make sense? If I multiply this out, my first one's give me 2 sine squared. That's my only sine squared. It stays. My outside is negative 4. My inside is plus 1. That gives me negative 3. And my last one's 1 times the negative 2 gives me negative 2. What factoring is a undoing of multiplying out. So if we recognize the pattern that our first one has to be 2 sine squared, there's only one option that can be there. It has to be 2 sine and sine. Okay? Then so I do that first. I figure out 2 sine and sine has to be first to give me 2 sine squared. That's the only thing that works. Now I know that my last ones have to multiply by 2, but now it matters the order. Because if I do 2 and 1 this way, then my outside is 2 and my inside is 2. That never makes 3. So I know that that has to be wrong. But if I do 2 here and 1 there, now my outside is 4, my inside is 1. Does 4 and 1 ever make 3? Yes. So I know this is probably going to be right. I need to get a negative 3. 2 times 2 is 4. You see how that's, my outside will be 4 sine x. My inside will be 1 sine x. That will make 3 sine x. Okay? Now, with the line, yeah, so think of these as like happy faces with a little nose. Okay? Yeah. Now you'll like this. Draw a pig every single time. You'll get it right. Okay? Outside is 4, inside is 1. That makes 3. I need a negative 3. So I need my outside to be negative 4, my inside to be positive 1. And then after I do this, because sometimes there'll be ones in there that'll throw you off, I do a quick check. Do my first ones give me this one? Yes. Do my last ones give me a negative 2? Yes. Okay? And does my outside and inside, the little piggy, work to be minus 3? Yes. Knowing that will allow you to factor things really quickly. And it connects the idea that factoring is just the undoing of foiling. It's backwards of foiling. Should we? So if foiling is one thing, backwards would be geniliof. That's what you should remember. Yeah, that's my, for this class, that's what we're going to name this kind of factoring. Geniliof. You just need to geniliof it. You can do it the other way. It's just, if you're using the grouping method, sometimes you put brackets where you need to have a plus or minus sign. So, like the grouping method, you break up this to be like a 2 sine x and a 3 sine x. Okay? So what are some of the things that happen with the grouping method? Actually, you would do, in the grouping method, you would do a sine x and a minus 4 sine x. So the grouping method, this is sometimes a mistake that I see in the grouping method. Okay, so we write plus sine x minus 4 sine x minus 2. Okay, first of all, you'd figure out that, there was sine and 4 sine. Then people factor out the sine x. Plus 1, and they factor out the minus 2. Oh, this one. Okay, sometimes I see people do this. Yeah, that's a mark off. Because they're like, oh, I'm going to think about this one and think about that one. Add extra brackets. It's hard for me to make mistakes because I don't practice them as far as what. Well, it depends where your brackets go. Okay? If
Where would be the correct placement for the bracket?
Okay, the brackets around this first one, let's take that away. This doesn't change anything mathematically, okay? But as soon as I put a bracket here and here, this technically means that negative gets distributed to be a plus 2, but it's not a plus 2, it's a minus 2. So if you'd have to take the bracket and change a sign, and that'll be confusing for you. So then some people say, oh, so I don't have that, I'll put the bracket here. Okay, but this means multiplying, and it doesn't equal what's above. So every time you write a statement, it has to equal what's above. And I find that the number of mistakes that are made with notation in this method end up costing you more. Plus, look, it's going to take you 1, 2, 3 steps before you factor it. And we're going to get questions where we're going to have like something to factor in your numerator, something to factor in your denominator, something to factor, like you're going to factor in 5 different places. And so if you're taking a long step for factoring, you're bound to decide not to write something and lose notation marks there. If we are able to, and this is why this I think is important, if we are able to go from here to factor right away, one step, then your notation errors are going to be less. You don't have to use this. You can use whatever you like. Just
You don't have to use it, but he's giving you absolutely no reason to use it.
okay. So then after you've factored it here, coming back to our question, this means that sine x equals negative 1/2, and this means that sine x equals 2. We're still solving, yes. We just got a little off topic with foiling and factoring and Gnillifi. Gniluf. Would you pronounce the G or is it just Niliof? Niliof? You like Gniliof? Like Gnus? Okay. When is x equal to negative 1/2? That is a great question.
No one say it. I think I got this.
It's quadrant 3 and quadrant 4. Pi over 6 family. 7 pi over 6 and 11 pi over 6. Is 2 on your pi plate? No, but you can still do this without a calculator.
Maybe you can.
Yeah.
When is sine x equal to 2?
Never.
Never. So you write,
That's right.
because sine is opposite over hypotenuse, this would be 2 over 1.
Oh.
And that can never happen.
Be a whole number, right?
It can never be bigger than 1.
Okay, it can never be bigger than 1, right?
Yeah.
Which sign can never be removed?
Sine and cosine. Tangent, no problem. Because if you think sine is your opposite over hypotenuse, we'd have 2 over 1. Hypotenuse has to be biggest. Okay? Now, check whenever you finish a question, especially one like this where we got distracted, right? We're finally at the end of this question 7 minutes after we started. Okay?
7 minutes on a test.
Check your domain. The domain was between 0 and 2 pi. We answered it between 0 and 2 pi. Whew.
So then
You're
put
just-
a box around your answer.
Our answers are done. We don't have to change them. Yes, as a rule of thumb, I like to start with between 0 and 2 pi, check my domain afterwards. The 0 and 2 pi is nice because it allows you to quickly rate the general solution. If this was a general solution question, you could just add 2k pi. And if it isn't, you can just find coterminal angles afterwards. All right, part B. Whew.
I wrote at the top for this one.
Sine x
Well, I taught myself how to factor on the top. So.
sine x equals cos x. We have a little bit of a trouble here because we can't just change things to sine and cos. We need to solve this, and we have two different trig functions.
Wait, why can't we just change? Oh, wait.
We can't change sine to cos, we can't change cos to sine.
Make them the same.
So two strategies that we could use to solve this one. One, you could just use your knowledge of the unit circle and say, I know the answer. When is the x coordinate and the y coordinate the same? Pi over 4. Anywhere else?
3 pi. No, 5 pi.
5 pi over 4. Good. So you could just use your knowledge of the unit circle and be done. Because they both have to be the same. They can both be negative or they both could be positive. Okay? If you wanted to use a strategy where you got this to a single trig function, watch what happens if I divide both sides by cosine. On this side, I'd get sine over cos. On this side, I would get 1. What could I change sine over cos to? Tan.
Should we have the negative positive sign for x equals then if it's cancelled negative positive?
Nope, because here you're solving for the angle, and we're just solving between 0 and 2 pi. If I change it to divide both sides by cos, I get sine over cos, and someone said you can change sine over cos to tan. Hey, now I've got a single trig function. Is tan ever equal to 1 on your pi plate? What family? Pi over 4. What quadrants? Because it's positive. 1 and 3. Oh, we get the same answer. That's it. I find that the first way is nice when you have both of them positive. I like the second way when one of them, like if there was a negative sign in front, then you have to think, okay, one of them has to be positive, one of them has to be negative. It gets a little confusing. I find changing it to tan works better in that situation. Okay, question number 10. How far in the proofs did you get?